In this example, we are introduced to the Caesar cipher. The Caesar cipher is also known as the shift cipher because each letter of a message is shifted a set number of positions down its alphabet. So the first thing we need to do in constructing any type of cipher is to establish a numbering system for the alphabet that's being used. Here we have this numbering system for our alphabet. Notice that the first letter A is designated 0, and of course then it increases numerically from there. And the reason we start with 0 for the first letter is that each letter has to be designated a positive integer less than the modulus. And for this, since we have 26 letters, our modulus is going to be 26. So you can imagine if we started A as 1, therefore B would have to be 2, C would have to be 3, and of course if we were to continue, Z would eventually be 26. So if we either had a ciphertext or a plain text and we wanted to convert it or encrypt it, if there was a letter Z, that would give us 26. Using our modulus, we would come up with 0 mod 26. And 0, this is the remainder, winds up being the designation for either the text or the plain text. And 0, there is no 0 because we started with 1. So here it says, encrypt the following message by breaking it into 5-letter blocks using a shift of 8. And then we have this message here, the quick brown fox. Now, breaking messages into blocks, for certain ciphers, which we won't cover here, you have to break them into a particular number of blocks. But essentially, there are two reasons we break texts into blocks. First, it makes it easier to manage that way, and it breaks up any patterns that may appear when within the cipher that would give clues to what the message actually is. So it's kind of a way of helping with the encryption. So the first thing we'll do is we'll go ahead and we'll write it out, breaking it up into those 5-letter blocks. QU, that's our first set of 5 letters. Here is our second set. And if you do not have 5 letters, you just tag on as many as you can. So we're left with X on the end there. Then we go ahead and we use our chart here to designate and label each letter its corresponding number. So T right here is 19. H is 7. E is 4. And we just do that. We just go down the line for each one. So once we've gone ahead and labeled each letter with its corresponding number, then we go ahead and do the encryption. So the Caesar cipher uses the encryption, C standing for the ciphertext. That's going to be equivalent to P, which is the plain text, which is the quick brown fox, plus the shift, we label that as B, and this is always going to be modulo 26. So here we have a shift of 8. So to change our first letter here, T, into our ciphertext, that's going to be C is congruent to P, which is our plain text, which is 19. Then we add the shift B, that's 8. And that's all modulo 26. 19 plus 8, that's 27. And 27 is congruent to 1 modulo 26. The remainder here is the designated letter or number for the ciphertext. So this becomes 1. And then we do that for each one. So for H, that's going to be congruent to 7 plus 8. 7 is the plain text, 8 is the shift, mod 26, and that is congruent to 15 mod 26, and of course 15 is then designated our ciphertext letter. And then we do that for each one. For E, 4 plus 8, mod 26. And as you can see, 4 plus 8 is 12. So 12 will be our ciphertext for H. And for the most part, since we know we have a shift of 8, we could pretty much just figure out what each one is here. 16 plus 8, that's 24. 20 plus 8, that's 28. That's 2 more beyond 26. So that becomes 2. 8 plus 8, that's 16. And then, of course, we do that as we go on down the line here. So as it continues, it's the same idea. Eventually, we have 23 plus 8 for X, mod 26. That's congruent to 31, which is congruent to 5 mod 26. So then once we've made the numerical changes, we then just go ahead and do their letters. Now don't forget, if T is 19 right here and you add 8, we could easily just go 1, 2, 3, 4, 5, 6, and since it's modular, 7, 8, and here's 1, it winds up being B. Or if we started with H, and we go 1, 2, 3, 4, 5, 6, 7, 8, that winds up being 15, as we can see right here, that's P. 12 is M. 24 is Y. 2 is C, and we go ahead and we fill out the rest of the text. And there we have it. So the quick brown fox would break up into this ciphertext.